Okay. Hello, everybody. Thank you for joining us this evening. My name is Lindsay Stone. I am the Native Plant Program Manager for Amargosa Conservancy. And tonight is our final botany webinar of our summer seminar series. And so thank you for being here tonight. We're going to hear from Chloe Novak. She is a master's student studying the flora of the Amargosa headwaters. And once Chloe's done presenting, there's going to be some time for questions. And this is also being recorded and will be posted on the Amargosa Conservancy YouTube page. And so if you want to watch it again, it will be there in just a day or two. And so with that, if you are ready, Chloe, you can go ahead and take it away.
All righty. Okay. Okay. Is that showing up? Okay. Great.
Yes.
Great. Okay. Thank you so much, Lindsay, and thanks also to the Amargosa Conservancy for inviting me to give this talk. And thanks to everyone who's tuning in. So I'm going to be talking about my current master's research, and I will repeat a few times the caveat that this is a work in progress, and I'm not done analyzing or even collecting all of my data yet. So I'm excited to share some of what I've learned so far, though. So if you've been following the Amargosa Conservancy, you're probably already familiar with at least a few of the very special plants that live in the Amargosa Basin and Ash Meadows region. But today I'm going to be taking us upstream to where it all begins at the headwaters of the Amargosa River. And I want to introduce you all to some of the amazing plants that are unique to the upper part of the Amargosa watershed. But first, I should probably address this question posed by the oddly existential road sign at the site of a proposed gold mine on public land at the Amargosa River headwaters. Namely, what exactly am I doing? So, more specifically, what is a flora? Why am I doing one here and why now? And then comes the fun part is what have I found so far? So in academic science, doing a flora falls under a branch of botanical research called floristics, which, among other things, is concerned with the documentation of what plants occur where. So we go out and collect a ton of data in order to figure out the diversity and distribution of plants, and the most important component of which is the herbarium voucher, a representative physical specimen of a plant that will enter a permanent collection where it can then be referenced and used in a wide range of research. So when we think of things like a species distribution map, for instance, these are often based on such herbarium records. But that brings up an important question. Have we looked everywhere? How complete are those records? So as it turns out, not very. This figure is from a 2014 paper by Dean William Taylor, and it shows the density of herbarium specimens, or the number of specimens per square kilometer by county in the Western US. It needs to be qualified with the very important caveat that it is more than 10 years out of date, and not only have many collections been made since 2014, but many historical collections have since been digitized as well. So we can expect that a more complete and up-to-date version of this figure will show greater specimen densities overall. But my colleagues and I have found that the overall pattern largely still holds. So floristic documentation in California, for example, outpaces that in Nevada by a factor of between 2 and 20. But of course, biodiversity doesn't just stop at arbitrary state lines, and one of the goals of my research is to help demonstrate that by filling in some of the missing data. I'm thankfully joined in these efforts by some phenomenal and dedicated botanists without whom my project would be severely impoverished. I don't really have time to discuss each of their contributions, but the ones on this slide have been especially influential for my work. Now, it's very important to clarify that the supposed data gap that I'm describing only exists and is a problem for contemporary Western science and settler society. So when I talk about documenting plant diversity or say that something was documented for the first time, I mean it only in this very narrow and specific sense. I use this system of Western science because it is tied to systems of power. It is what is legible to land managers who decide what gets bulldozed and what gets spared. I'm conducting my research on land that has been continuously occupied, stewarded, and sacred to the Niue, Oristun Shoshone, and Nuuvi, or Southern Paiute peoples, for many thousands of years. And throughout that time, the Amargosa River has been central to all human and non-human life in this part of North America's hottest and driest desert ecoregion since the late Pleistocene. The study area for my flora encompasses the uppermost portion of the river system and all accessible portions of the contributing watershed, and it's roughly 2,000 square kilometers sandwiched between Death Valley and the Nevada test site. So if you're familiar with this region, you already know that it is indeed a desert, and the extreme conditions can both drive the evolution of extraordinary organisms, and they can also make this work sometimes very challenging. In the dry uplands, precipitation is everything, and it is very fickle in the rain shadow of the Sierra Crest, as well as multiple mountain ranges in between. But down in the wetlands, groundwater is everything. And even in a year with no rain, they teemed with life even through the hottest part of the summer. So while the river itself is obviously the main event of the Amargosa headwaters region, what was most exciting to me as a botanist is the incredibly diverse geology of this area, featuring noted drivers of edaphic endemism like ancient limestone and dolomite, volcanic rhyolite, ash tuff, and basalt, metamorphics, and alluvial derivatives of all of the above. All of which are arranged in a very rugged basin and range topography with some bonus volcanic features. So when you oops, sorry. When you add water and the wonderful forces of biogeography and evolution, you get an incredible diversity of habitat and vegetation types that reflect a confluence of the Great Basin and Mojave ecoregions, as well as connectivity to major areas of endemism, including Death Valley and Ash Meadows. And this combination of factors in a botanically underdocumented area makes for a very compelling floristic study. But But some of those same factors have also attracted a very different sort of interest in the area, namely that of industrial capitalism. The scale and pace of industrial development in this area is truly staggering, as is the fact that it goes virtually unnoticed despite occurring immediately next to a national park and at the headwaters of a river that supports the highest concentration of endemic species anywhere in the US at Ash Meadows. Current major conservation threats include proposed massive open pit gold mines. So the multinational, multi-billion-dollar mining corporation AngloGold Ashanti and its various subsidiaries own active mining claims covering virtually all of the mountains surrounding the town of Beatty. They are focused on two areas for large open pit gold mines. The first is the proposed North Bullfrog mine, which the BLM is currently deciding whether to permit on the basis of the draft environmental impact statement released this past May and any substantive comments that were submitted during the 30-day public comment window. If permitted, that project alone will likely drain the wetlands of Oasis Valley, dry up dozens of springs, and directly impact numerous rare and threatened species. But the North Bullfrog project is only the appetizer for their ambitions in the area. So across Highway 95, they have been busily excavating a sprawling complex of access roads and drill pads that they now wish to expand into a much larger consolidated exploration project spanning some 6,300 acres or roughly 10 square miles, for which they sought what is called a determination of NEPA adequacy, or DNA, which would effectively preclude the analysis of cumulative impacts. So in addition to gold mines, there are also proposed large-scale lithium mines, energy infrastructure development driven now largely by data center demand. Specifically, the Greenlink West high voltage transmission line is currently under construction through the middle of the study area with major impacts to Joshua trees, desert tortoises, and vast quantities of groundwater pumping for dust suppression. Additionally, much of this area is prioritized under the 2024 Western Solar Plan for utility-scale solar developments, and these are quickly moving in along the Greenlink West corridor. And all of these projects inevitably entail pumping thousands of acre-feet of groundwater for their construction, maintenance, and operation. Now, a point that I want to emphasize is that it's not purely coincidence that places with less well-documented biodiversity are more likely to be developed. In this case, an absence of evidence is often mistaken for the evidence of absence, and it's much easier to advance a project when it only needs to clear minimal environmental review requirements. And of course, all of these threats are converging on a landscape that is already vulnerable due to the more ubiquitous conservation challenges affecting public lands in the American West. Climate change, invasive species, OHV incursion, and increasingly the threat of public land sell-offs. So, my project is largely motivated by this context. Figure out what all is there so that it stands a chance of being protected. So what does this look like? Well, so far I have wandered the desert for 164 plus days of fieldwork, surveying and collecting vouchers of plants with sampling priorities informed by historical documentation gaps, as well as the context of these imminent conservation threats, all while aiming to maximize geographic, hydrologic, edaphic, and taxonomic coverage. So prior to the start of my research, historical herbarium vouchers were concentrated along major roads and were entirely absent from large areas of the study area. But they did represent an impressive 581 species and subspecies. The majority of collections were also more than 50 years old and thus warranted resurvey given both climate and land use change in the intervening decades. So here's where I'm at so far. My preliminary checklist contains 742 minimum ranked taxa with more than 160 added through my fieldwork so far, or roughly 20% of the checklist, and 22 of those added taxa were rare species. I expect that that number will likely increase, certainly change as I complete my late season fieldwork and identify all of my specimens this fall. But those numbers don't really tell us very much about the plants themselves. And while I would love to show you all 742 of them individually, what I really want to do is give you a sense of the unique landscapes and ecosystems that they are all integral parts of, and that you have likely only encountered going 80 miles an hour on 95, praying that you survive the semi truck making a risky pass in the oncoming lane. So I broke the study area down into major geomorphic and biogeographic chunks, and even then there was still too much to cover, so I had to make some really tough choices, and unfortunately, the North Amargosa Valley and Paiute Mesa Yucca Mountain areas lost this round. But I promise that they also have incredibly interesting plants, so feel free to ask me about them, or you can wait for me to cover them in a future talk. But for now, buckle up because we have a lot of ground to cover. So our first stop is the Grapevine Mountains Wilderness Study Area, which comprises the portion of the Grapevine Mountain Range just outside the Death Valley National Park boundary. It's managed by the BLM as a wilderness study area, meaning that it has been identified as having wilderness characteristics and could be designated as a wilderness area, but it does not hold any of the protections afforded to wilderness areas except for a lack of road access. And because these mountains are so intensely rugged, that lack of road access is probably one of the reasons that this area had almost no herbarium collections or floristic documentation prior to my research. Unlike the carbonate formations, which dominate on the California side of the grapevines, this portion of the range is mostly composed of volcanic rocks and metamorphic rocks. And that difference is definitely reflected in the flora, with different plants that are adapted to substrates with different physical and chemical properties. So the higher elevation mountains in this area feature more characteristically cold desert Great Basin plant communities with pinyon-juniper woodland and sagebrush scrub. But the Mojave influence persists even at mid elevations with Joshua trees blending into the pinyon zone. This area also has a very high density and diversity of native bunch grasses, geophytes, and bulbs, and a lot of plants that are culturally important in Tibisha and Nuovi culture, especially with the pinyon being central to local foodways. And on that note, I can't talk about this landscape without mentioning the phenomenon of pinyon-juniper dieback, which is primarily attributable to climate change and is driving landscape level type conversion in the grapevines and across the Southwest, which threatens many species that depend on this vegetation community. By contrast, this area is home to a relatively healthy and robust population of the Western Joshua tree, which dominates on the east draining Bajadas. So since this portion of the grapevines was truly a floristic black hole, it has been especially interesting to compare what we've found here to the much better documented flora of the rest of the Grapevine Mountains within Death Valley National Park. So prior to my fieldwork, none of these plants were known to Western science to occur in the grapevines or in any other Death Valley mountain range. Below each plant, I've shown its documented regional range map with a red star depicting where I documented it in the grapevines. And while none of these plants are considered particularly rare or threatened, filling these gaps in our knowledge of plant distributions is important for understanding plant evolution and ecology and biogeography. And this can help inform future research on these plants or the communities that they inhabit. So for instance, a future researcher studying any of these species in depth will probably want to look at plants from isolated occurrences like this because they might turn out to be significantly different from others, especially at southern range limits in the context of climate change. Other noteworthy and rare plants. All of these plants are locally rare, regionally endemic, or in some cases both. If you're tuning in from Southern California, the buckwheat down at the bottom right might not strike you as a very noteworthy or rare plant, but this species is actually quite rare in Nevada. So as I mentioned, most of this portion of the grapevines is composed of volcanic rock units, but there's a notable exception in the westernmost corner where sedimentary and carbonate units bleed over the border, along with several species that have made Esmeralda County records. Many of these plants will seem familiar if you spent a lot of time in the Death Valley region, but they really are quite uncommon in Nevada and especially this far north. Um, and another thing I wanted to point out is that because many of the dominant plants in the grapevines are not found in other parts of the study area, many parasitic and hemiparasitic plants that specialize on these plants have followed their hosts here too. So these include two types of mistletoe that are specialized parasites of the two conifer lineages on the landscape, junipers and pinyon pines. And what I find really remarkable is that the plants here have all convergently evolved a parasitic or hemiparasitic lifestyle, but they actually belong to three distantly related evolutionary lineages. So the dodder belongs to the morning glory family, Convolvulaceae, while the mistletoes belong to the sandalwood family, Sandalaceae, and the colorful summer roots and paintbrushes belong to the Orobanchaceae and are more closely related to the mint family than they are to any of the other parasites shown here. All right, on to the next stop. So our next stop on the tour lies just northeast of the grapevines, and from a distance, it might not seem like a very exciting place to stop and look for plants. But the name already gives it away. It's named for one of the dominant shrubs in this basin, Sarcobatus, aka greasewood. These plants belong to their very own family, Sarcobataceae, and that family contains only two species. So by comparison, the sunflower family contains some 32,000 species. And you can find both of the species on Sarcobatus Flat. So etymology dorks will appreciate the species name vermiculatus means worm-like in reference to the very much worm-like inflorescences, while fellow metalheads may appreciate that Sarcobatus itself means flesh bramble. And as far as I know, that has not yet been claimed as a band name. So if you come at the right time of year after a good wet winter, you might run into a veritable super bloom featuring these and many other annual plants. And if you look closer, you might also come across some of the many rare species that occur on Sarcobatus Flat. So I want to highlight Penstemon arenarius, the Nevada endemic dune beard tongue, and the really stunning carrot relative Cymopterus ripley, and the almost invisibly tiny Linanthus arenicola. So I found new populations of all of these plants on Sarcobatus Flat, and I was able to make conservation seed collections for some of them this year with support from the Center for Plant Conservation. Now, the most noteworthy plant on Sarcobatus Flat, in my opinion, is the extremely rare and threatened Sotaville milkvetch. It's known from only 6 global occurrences in groundwater-dependent alkaline wetlands, and it's state listed both in California and Nevada. But as we'll see, this has not been sufficient for its protection. All of its populations are threatened by climate change and the erosion of public land protections, but its 5 occurrences in Nevada are imminently threatened by industrial resource extraction, development, and groundwater pumping. This plant was a major factor in my decision to do a flora of this area, and it also was the catalyst for the formation of the long overdue Astragalus Appreciation Society, which convened its inaugural Milkvetch Madness Sotapalooza survey event in May of 2024 to survey recently documented occurrences as well as potential habitat for this plant. That event was a huge success, and I used the data that we collected in a conservation plan that I drafted that fall for a course taught by my advisor, Dr. Naomi Fraga. So as of last year, my primary concerns for the Sarcobatus flat population of Sotaville milkvetch were proposed lithium mines on its habitat, as well as groundwater pumping for proposed gold mines to the south. On May 20th, in preparation for our second annual Sotapalooza survey, I went to check on the population at Sarcobatus Flat and scout survey plots. But what I found was a construction site directly on top of the plants. I got on the phone with the Nevada Natural Heritage and the Center for Biological Diversity to try to find out what was going on. But at that point, I knew more than they did. And that is how I unwittingly became a whistleblower in a conservation emergency. So as it turned out, NV Energy was getting ready to construct high voltage transmission towers weighing 60 tons apiece and an access road connecting them directly through the tiny fraction of Sarcobatus Flat where Sotaville milkvetch grows, which is about 150 acres out of an area more than 50,000 acres. Besides being kind of absurd, this was actually illegal because the Sotaville milkvetch is listed as endangered under the Nevada state law. And if you want to bulldoze it, you are required to at least get a permit from the state forestry office first. So even if it wasn't state listed, though, it is listed as a BLM sensitive species, meaning that impacts to it definitely should have been analyzed under the environmental impact statement for Greenlink West, but they definitely were not. So we shifted the focus of Sotapalooza 2025 to document these visible impacts on the ground, and I put the data that we collected straight to work, first in a formal report to the Nevada state agencies and BLM, and second in a 90-page Federal Endangered Species Act petition that I collaborated with the Center for Biological Diversity on. So by the middle of June, construction was paused. Sotaville milkvetch got a little bit of press coverage. We submitted the federal ESA petition. And eventually, my anxiety over how I was going to chain myself to a prostrate herbaceous plant began to ease up. So for this year's Sotapalooza, we made conservation seed collections, collected tissue samples for future genetic research, and established some long-term monitoring plots. Now, the fight to save Sotaville milkvetch is far from over, but right now it's time for the next stop on our tour. So while we know that there is groundwater flow between Sarcobatus Flat and Oasis Valley is where the Amargosa River begins in earnest with perennial above ground flows. There's a ton of endemic biodiversity and all of it is connected to the groundwater. Shown here is the fireflies that have recently been documented, which is incredible. There are not a lot of flying fireflies out west. So despite being the most densely populated portion of the study area, the wetlands, meadows, and riparian woodlands were hiding a lot of really interesting plants that weren't previously documented for science. Many of these have important cultural uses, and some of them, like the springbank clover, are noteworthy largely due to their apparent absence from the lower Amargosa. All of the rare plants in Oasis Valley, like the endemic wildlife, are totally groundwater dependent. At the California Botanic Garden, I'm very lucky to get to work with the very smart researchers, including my advisor, Dr. Fraga, Dr. Carrie Keel, and Marife Akupomo, who figured out that the federally listed spring-loving century, Wiltner anemophila, does occur outside of Ash Meadows, including in Oasis Valley, where it shares its alkali wetland habitat with all the other rare plants shown here. Oops, sorry. As I mentioned previously, these plants are imminently threatened by groundwater impacts from proposed gold mines, and their continued survival will depend on a lot of sustained advocacy in the face of some very powerful profit-driven interests. I hate to move on, but we still have 2 stops to go, and next up we are traveling to the Bullfrog Hills just west of Oasis Valley. So the Bullfrog Hills were not, as I had previously guessed, named after a misidentified Amargosa toad, but they were allegedly named because someone thought that the ore that they mined from here was bullfrog colored. If you don't know, bullfrogs are an invasive species out west, and the story goes that they were brought over during the gold rush, essentially as livestock for their meat. So, like the part of the Grapevine Mountains I described earlier, the geology of the Bullfrog Hills is primarily volcanic, including a lot of colorful ash tuff and rhyolite, hence the name of the famous gold mining boom town in the Bullfrog Hills, which lasted only 15 years before becoming a ghost town by 1920. But let's get to the plants. So the plants that I've chosen to highlight here are not considered rare, but they illustrate the interesting melting pot biogeography of this area. So at bottom left are two plants that weren't previously documented here, and bottom right is a very cool mustard known by the common name dagger pod, which just barely makes it into the Death Valley National Park boundary and reaches its southernmost distribution in Nevada here. The yellow-eyed lupin, Lupinus flavoculatus, was first described as a species from a specimen collected in the Bullfrog Hills, along with several others that I will discuss momentarily because they are rare. Here are a few of the earliest blooming rare plants in the Bullfrog Hills, including some that were not previously documented here. Some of these really find their niche on desert pavement, which is a unique gravel substrate consolidated with biocrusts that is like lichen, bryophytes, algae, and fungi, and often is recognizable by a uniform patina or desert varnish, which is a thin brownish orange layer of mostly clay minerals that are deposited by wind over time. Here's another batch of rare plants, these ones tending to bloom a bit later in the season, all the way through September in the case of Eriogonum panamentense. I want to give a special shout out to the local grassmaster, Laura Cunningham, who first noticed and keyed out the Muhlenbergia, which was hidden away at a spring. So Astragalus funareus is among those plants that were first described from specimens collected in the Bullfrog Hills. And it's very appropriate because this area, it really is the center of its whole world. It has a few isolated occurrences in the Death Valley region, but it is otherwise most abundant here. And that's kind of unfortunate because it is not really well protected here at all. Due to its rarity, as well as its apparent affinity for highly sought gold deposits, I really think that this plant warrants listing, at least at the state level, to ensure its long-term survival. And finally, the Bullfrog Hills are, of course, where you can find the Bullfrog Mountain pea, Lathyrus hitchcockianus, a bit of an unfortunate scientific name for a really lovely plant. Like Astragalus funareus, this plant has a super restricted range and is in fact nearly endemic to my study area and to Nevada. It just barely crosses the border into California. And likewise, it has a habit of living in the path of proposed gold mines, and with even fewer populations and a narrower range, it's going to need better protections to evade extinction. So I could talk all day about the flora of the Bullfrog Hills, but I just checked the clock and it looks like we're coming up on lime time, by which I mean it's time to hit the limestone. So for the last stop on today's tour, we will be visiting the Bear Mountains, which is a range composed of mostly carbonate rock that stretches south from Beatty to the east of Highway 95. Now, this was the view that really sold me on doing a flora here because I just had to know what was growing in those rocks. And the fact that someone had the idea of calling them bare as though they were barren and devoid of plants, I guess I just felt compelled to disprove that. Oh, and this entire mountain range is also under active mining claims with massive exploratory drilling operations rapidly expanding. So by now you've maybe picked up on the theme that plants can be kind of picky when it comes to rocks. In my line of work, this phenomenon has a government name and it's edaphic endemism, which broadly refers to any organism in nature that is specially adapted to or otherwise restricted to a specific substrate. It gets complicated pretty quickly from there, but at least within this study area, these plants are pretty well restricted to carbonate substrate and qualify, in my opinion, as lime-time endemics. So one thing about endemism is that it tends to coincide with rarity. And oopsie, here's no exception. The Bear Mountains are home to a ton of really cool rare species that are typically only found on carbonate substrates. And yes, one of these was a very exciting find. Loesia maguirei is a tiny, fleshy, succulent perennial that until recent years was thought to be endemic to just a couple of mountain ranges further east. So since then, fellow lime-time botany fanatics, including Matt Berger and Matt Reala, have found this plant in several new occurrences, including this year in California for the first time. I was really pleased to document it in this place because this one seems to be its lowest known elevation occurrence, but I do need to double check that, but that could be significant. Another really interesting case of disjunct distribution is Glossopetalon pungens, which is otherwise known from a handful of occurrences further south around Las Vegas and the Clark Mountains in the Mojave Preserve. It was actually documented here in the early 1990s, but had seemingly flown under the radar with no reported sightings or collections for more than 30 years until we found it again on a terrifyingly steep north-facing ridge. And of course, can't forget this guy. We found the first Nevada state record of the Death Valley monkey flower during my first field season, and this was about 20 miles east of its nearest known population in California. So it was never an explicit goal of this project to dethrone California endemics, but it does help to illustrate the value of floristic research. So in California, Diplicus rupicola is considered rare, but it's given the lowest rare plant rank of 4.3, largely owing to its relative protection within Death Valley National Park. But in Nevada, its sole known occurrence is under and completely surrounded by active mining claims. So since 2024, I've been working with the Nevada Natural Heritage and BLM to hopefully secure some degree of protection so that this plant doesn't truly become California endemic after all. So Diplicus rupicola is one of 62 rare plants currently documented in the Amargosa Headwaters study area, more than a third of which were documented through my fieldwork so far. While I've talked a lot about rare plants, I hope that I've managed to convey that they truly are just the tip of the biodiversity iceberg here. They may be especially vulnerable due to their rarity, but so is the entire web of life that they are integrally enmeshed with. So I used to emphasize that plants in general are uniquely vulnerable because they are rooted in place and cannot move themselves out of harm's way. And while that is true on some level, I think it's more accurate to say that their vulnerability extends throughout entire ecosystems that are equally tied to the place that a plant is rooted in. I'm basically paraphrasing what the OG ecologists were saying before the field became obsessed with computer models and functional traits. No shade to anyone. We're in a desert. There's not enough to go around anyway. So to illustrate what I mean, I don't think you're going to be able to hear this, but this is a rare plant. And although you wouldn't suspect that it is rare along the Amargosa because it really thrives here. It's called Cleomella obtusifolia or Mojave stinkwort. And it is a little stinky, but I think it's really more deserving of the common name given to some of its close relatives in the genus Cleomella, which is bee plant. This is the magic of this place and these plants. It's 100 degrees in late August, and there's just so much life here. And it's scenes like that make statements like this one from the draft environmental impact statement for the North Bullfrog gold mine seem almost pointedly careless. And that was just one of many oversights and errors that my fellow concerned citizens and I scrambled to refute during the 30-day comment period for that project, which ended on June 8th this year. So if you recall, under Biden, the mandatory minimum period was 45 days, which I don't know, maybe would have helped, but the current deregulatory context does make this work more challenging because now it's not just the biodiversity that is vulnerable, the mechanisms that were designed to protect it are too. But who doesn't love a good challenge? There's so much at stake here, and it's not too late to protect it. The amazing plants that call this place home have evolved to live in some of the harshest conditions on the continent, and all we have to do is let them keep their homes. The extinction crisis here is not inevitable. So get informed, stay engaged, and above all, appreciate plants. And with that, I'm done. Thanks again to the Amargosa Conservancy for hosting. Thank you all for listening, and especially to all the people and organizations that have made my work possible. Truly could not do it without a community. And yeah, I'm happy to take any questions.
Thank you, Chloe, for that wonderful talk. Yes, if anyone has any questions, you can either put them in the chat, or if you raise your hand, I believe I can unmute you and you can ask it that way. Okay. Lawrence, I will unmute you so that you can ask your question. Do I know how to do that? Okay, Florence, I think you are unmuted, or you can unmute yourself now. If you're speaking, we can't hear you. Okay, it might be easier to just type. I know we have some in the chat, so I am going to mute you, Florence. And if you do have a question, I think it might be best to type it in the chat. Okay. So, first question for you, Chloe, is so what can we do?
Ah, yeah.
Good question.
Um, Thanks. Great question. Um, yeah, so as I mentioned, the public comment period for the first of the big gold mines um is now over. However, what it did reveal to me was that there are a lot of people, groups, and causes that are really allied on protecting the Amargosa River and its headwaters and its biodiversity. Um, and while there's all of that, there's not really currently like a unified advocacy hub that covers the headwaters. And so I think that there's some room for folks to really like step up and step in and get involved. And let's see. So yeah, getting ready and sort of being prepared, especially like for the next public comment period, I think is a great idea. Um, I wish that I had more time and resources and energy to devote to all of the advocacy that needs to be done. But I'm really happy to sort of share my, what I can contribute with folks who might have more of those resources on hand.
Wonderful. Somebody else asked, are there any symbioses between plants and animals or insects in the Amargosa River Basin that you find particularly interesting?
Oh man, tons of them, yeah. Um, so in addition to like the parasitic plants that I mentioned, there's I am always finding really interesting galls, and those always catch my attention. Some of them have been very exciting to other researchers. So I found a gall on this little tiny annual in the sunflower family called Prunanthella exigua. And I put it on INAT, and a researcher got in touch and was like, "Oh my God, you found the thing that I predicted would exist." Because I guess they were studying related genera of asters out east that all had these gall forming, I think it was a wasp, um, associated with them. And they were like, I bet that there's something out west. And that one is just so cool because this is an annual. And like I was saying, in a dry year, you don't get annuals. So whatever this, symbiont is doing to that, it must rely on this plant to complete its life cycle. But does that mean that it just doesn't do anything in dry years? I don't know, but I think it's super cool. Also, use INAT and document your goals because people get really excited about them. But yeah, I could probably come up with a bunch more. Yeah.
Somebody else asks, how did you decide to map each of the regions you studied?
Oh, well, I guess I think of each of those as like if I'm planning field work, it's like those are the chunks, I can really only do one chunk in a day, or visit one chunk in a day because the study area is massive. So that's one reason, but also they make a lot of sense sort of biogeographically. Um, they have a lot of sort of continuity within themselves, even though there's obviously a lot of overlap and blurry lines. So yeah.
John Hyatt asks if you have seen standing hollow tube mine claim markers in the Bullfrog Hills.
Oh yeah, yeah. I knock them down. I think that that's what you're supposed to do. Knock them down and leave them there. I That's what I've been told.
Someone else asked, how feasible is cultivation for these rarer and threatened plants for preservation?
Yeah, that's a really good question. To be honest, I don't personally have a lot of faith in ex situ conservation for a lot of these. So, for instance, like the Sotaville milk vetch, its habitat specificity is so ridiculously extreme. It only occurs in a tiny fraction of these endorheic basins and alkali wetlands. Um, could you get one to germinate and grow? Maybe. Would it really be the same thing as Sotaville milk vetch in the wild? I don't think so. But that's just my opinion. And I'd love to be proven wrong about some of that, and there's probably more opportunity. I think penstemons tend to do really well in cultivation, so it's possible that you could get Penstemon arenarius to grow, and that's one that I've collected seeds from. Um, Astragalus funareus might have a little, I don't know, it would be a really cool plant to grow because it's just so cool and so cute. But I don't know. It likes really steep loose talus, so I don't know. Yeah, maybe that wouldn't do well in a garden.
I see quite a few questions about asking if you ever need help or if you train. And I think for any of those types of questions, if you want to reach out to
Yeah.
Chloe at the email that she has on that this slide that's up, I think that's a good idea. And there's also a lot of questions about wanting to watch this again or look at the slides. Just as a reminder, we're going to be posting it on the Amargosa Conservancy YouTube, so you'll be able to see everything there in case you missed anything or want to look at something more. Um, Somebody else is curious to know about what brought you to the Amargosa and what your background is. Um,
Oh gosh. So the Amargosa headwaters as a study area was my advisor's idea. Naomi does a lot of work in the Amargosa, and but I already knew that I wanted to do a flora in Western Nevada. Western Nevada mostly because well, if I was going to do a flora and if I was going to do it as a grad student out of California Botanic Garden, then it was going to have to be like within a 6 hour drive, and there's just not that many places. And I definitely wanted to work in Nevada because of that, major disparity in botanical attention, basically in Nevada, and also just this huge number of threats that are really converging, um, in especially the desert regions. So yeah, it was really a combination of things, but I think it's the context of the threats that made it really feel urgent and really compelled me to work on this area.
and then there's another question about if you've had the opportunity for dialogue. I think for native residents, I think they are talking about like having tribal knowledge or coordinating with tribes.
Yeah, that's something that I would really love to pursue further. So I know Amargosa Conservancy has some cool collaborations going on with the Timbisha, and I would love to help with that and also provide my data in a way that's most useful to local tribes. And I'm really looking forward to some, future collaborative opportunities for that.
Okay, we're just gonna do a couple more. One of them is, I believe the Amargosa Basin extends into the Nevada Test Range. If so, have you tried to explore inside this area?
Yeah, so actually the true headwaters of the Amargosa arguably is sort of extending up into the test site, or rather, Nellis Air Force Range. Um, so it was theoretically possible to get access. However, logistically almost impossible. You can't really do work in the test site without like a military escort, and it's very expensive to get one of those. And it was way outside the realm of my budget constraints. So that wasn't going to happen for this project. There's also a sort of funny strange joke in Nevada that the military is one of the best conservation organizations. I don't know that I would necessarily agree with that, but it is true that they aren't actively mining immediately next to the Amargosa headwaters in the test site currently that I know of. I don't know, could be wrong.
Okay, and finally, do you have any field guide recommendations?
Ooh, field guides. Field guides. That's a really good question. Not off the top of my head. Um, I hope that the flora that I produce for this will become a like an accessible reference for plants in the area. There are some really cool books. Let's see if I have anything. Um, so this one is cool because it has like ethnobotanical information about some of the plants in southern Nevada. I don't know if that covers quite what you're asking for, but yeah, get in touch. I'll try and think of some more resources.
All right, I think that is it. Thank you, Chloe, and thank you everyone for joining us. Again, Chloe's email is up on the screen right now if you want to write it down or screenshot it, if you need to reach out to her with any more questions. And this whole webinar is going to be posted on our YouTube page, so you can watch it there as well. And you can watch our previous ones if you missed those. So yeah, thank you, Chloe, and thank you, everyone.
Thanks, everyone.
Have a good evening. Bye-bye.